Okay, so let's get started. Let me go into full screen mode. Okay, good evening, everyone. To all those joining from India and France, and good morning to all the participants joining from the US. Firstly, thanks a lot for participating in the first 2 days of the meeting last week and making an effort to join us in this final discussion day as well. So I would probably spend around 5 minutes trying to get a plan going for how we can organize this session. And then I will hand it over to the panel members to take the discussion forward. We would very much like, apart from the panel members, we would very much like the audience also to provide their inputs. So if please either unmute and speak, or if you think that's interrupting the discussion, you could post your question on the chat box or simply raise your hand. We will look for any of these signatures to make sure we receive all your inputs. So we had a very productive 2 days of meeting last week on September 7th and 8th. There were several talks, understandably short, because we wanted to make sure we have an introduction of everyone who's part of the center. And based on discussions with many of you, we have evolved some plan for this discussion. And at the forefront, I would like to just say that if there are some talks that I have missed covering entirely or missed some names, please accept my apologies. I have not had the time to go through all the talks yet, but surely we will be discussing further even after today's meeting. So the main goal for this meeting is to discuss the science objectives that could be taken up under this research initiative called Geophysical Flows Lab at IIT Madras, and broadly identify the various groups that could work on different aspects. We may not be able to, we don't intend to finalize all details today. We would just like to identify the main problems that we would take up, and we will surely keep in touch after the meeting as well. So there are already several collaborations that are ongoing within this group, including the analysis of an extensive amount of open ocean observations that have been performed in the Bay of Bengal. We did get a flavor of these extensive observations in many of the talks last week. There are also collaborations on large-scale climate models and laboratory studies on internal waves and other fine-scale processes that are ongoing as well. So we thought, in addition to strengthening these ongoing collaborations, which the center certainly aspires to do, we will also identify specific science questions that we would take up going forward. And it seems like focusing on coastal processes in the Bay of Bengal, we will see why, is emerging as an important theme that we should take up. So I would like to spend around 10 minutes discussing the science questions and 20 more minutes on making an observation plan and talking about the various new measurements, including unmanned aerial systems and autonomous boats that could be made use of for these field campaigns in the coastal Bay of Bengal. Then we will spend 10 minutes each on large-scale modeling studies, fine-scale processes, and experimental modeling. These are rough times. We will try and stick to these times, but if we cross these time limits by a little, I don't think it's a big issue, because we have an entire 2-hour slot available to us. Sorry, my screen is frozen. Yeah, okay. So to get the science discussion going, I would like to reproduce this very nice slide that Craig and Eric showed in their first talk last week. They highlighted that while the monsoon may predominantly contain features at large scales, both in space and time, it's significantly influenced by the sea surface temperature, which in turn is actively influenced by a wide range of dynamics at a wide range of spatial and temporal scales. So this means understanding processes across these ranges becomes important. And we also saw talks about how the sea surface temperature may influence air-sea interactions. And there were some talks that focused a little more on understanding some of these fine-scale processes. So one of the ideas could be to perhaps focus the field observations under this initiative on coastal processes, which would include submesoscale and internal waves. And the modeling and the fundamental studies could span the entire spectrum. But I'll let the panel comment more on this big picture point. So I would just get started by showing a picture again that Eric kindly shared with me. This talks about measurements from a couple of decades ago, more than a couple of decades ago, that showed that coastal upwelling is indeed a phenomenon that occurs in the western boundary of the Bay of Bengal. And an interesting question that's been recognized for a while now is that why is the Bay of Bengal on an average during the monsoon warmer than the western boundaries in the Arabian Sea? So that could be an interesting topic that we take up. Of course, coastal processes always involve the dynamics associated with boundary currents. So coastal upwelling and boundary currents are two processes that we thought we could focus more on. So I will start with posing the question of our coastal processes, including coastal upwelling and boundary currents, potentially important theme to focus our observations on. And just to guide our discussions, I've listed out several aspects of this question, including ship-based measurements that would be possible, that are already ongoing. So we would really be eager to listen to the Indian national labs on their thoughts on making these observations. Unmanned aerial systems is a significant technology development aspect in this initiative. So what are the various new measurements that could be enabled by these unmanned aerial systems? There were quite a few mentions of autonomous systems as well. There are already existing data sets that we could take advantage of, including bottom-mounted ADCP and high-frequency radars. And if possible, if time permits, we could have a short discussion on constraints related to making measurements in the coastal regions and the vessels that could be used. Okay, at this point, without taking much more time, I will hand the stage to Eric and Amit to carry forward this discussion. Eric and Amit.
Hello, everybody. I thought a little bit about this one, and we should get lots of comments from other people on the panel. I think it's important to have a geographical focus. I mean, because there's a big seasonal cycle, to do similar measurements of different types over a long period of time. I think that's really important. It also means that if you repeat these measurements over and over again, you start to see phenomenon and patterns, and that provides gist for theoretical and laboratory studies. There was a really nice example of this in the United States, where Rutgers University declared an ocean observatory off the coast of New Jersey, put some instruments out there, and over a period of 20 years, that built into a really big and successful program. So I think of that as a prototype. There are a couple places where there already are observations being made along the coast of India. I don't have a chart, but there are coastal radar systems at 4 sites. Well, I think 3 sites along the east coast of India and 1 in the Andaman, and I might be wrong about that. And there are also places there where there are bottom-mounted ADCPs measuring velocity looking up. And I think those would be really good places to start using some of these new systems that that this program is building up, like the aircraft, for example, so that you have a context. And this all may be pretty obvious, and I don't know the internal logistical constraints, but that seems like a good place to start a program is pick a region or maybe two regions, off Chennai and off Orissa maybe would be obvious choices, and then start repeating measurements in that region and slowly build up an understanding. Amit, you have something to add to that?
No, that's a really good start, Eric. The science questions we already know that the boundary currents and the coastal processes are quite important in setting the stratification. You pointed this out in one of your ICERM talks. This came up again in Amala's talk last week. So I think monitoring coastal processes is, scientifically it's really important, and I think, and your placement, geographical placement, relying on both past measurements and where past studies have been, and setting up coastal observatories there is a really good one. It's a really good suggestion. I know that we have Patabi from INCOIS and we have Venkat from NIOT who can perhaps also talk about NCCR. So I wanted them to sort of chime in and talk about what is already in place and what's already going on, and where they could see could be really built up with the additions of these new systems, with the UAVs, and sort of a cohesive planning across these many participants from the center that can come together to make this happen. So I wanted to open it for a couple of minutes. So Patabi, if you can unmute yourself and sort of talk about some of the things that are going on, or Venkat from NIOT.
Yes, Amit, I'm here. This is Patabi.
Sure.
Can you hear me?
Yes.
Okay, shall we go point by point? First, shall we discuss on the classical ship-based and satellite observations?
Sure.
Yeah, ship-based, actually, see, as I mentioned in the presentation last week, see, we have sustained observing system for the open ocean to meet our operational requirements, to provide services. Whereas we do not have sufficient or observations from the coast. That is evident from the previous week's talk. So now our next 5-year plan, we are going to concentrate on the coastal observing system. And of course, I can say now the point one, classical ship-based. When you say about classical ship-based, what we have at present, INCOIS has installed automatic weather stations on board 34 research vessels of Ministry of Earth Sciences, Shipping Corporation of India, Geological Survey of India, Naval Hydrographic Office, and some other research vessels. So they will be mostly plying around the coast and providing marine meteorological observations from the EZ. Mostly they are very near to the coast. We have got very good coverage of the coastal areas where we do not have any single observation. In fact, we have got first ever highest winds recorded on our automatic weather stations during one of the cyclone in Bay of Bengal. So we are going to sustain this network ship-based, and probably we have in fact, we have planned for a few more, but because of budget restrictions that arise due to the COVID, we were unable to execute, but we are going to sustain this network, and we are going to have these observations, ship-based automatic weather stations. We are going to have 34 in the next 5 years. And these data we get in real time, and then it gets into the GTS in the WMO standard formats for its operational use in the operational weather forecasting. So that is as far as ship-based marine meteorological observations are concerned. And then we have, as I mentioned during last week, now INCOIS is planning to establish coastal water quality buoys all along the coast. Initially, we thought we'll have 6, but again, because of restrictions, we have now planned for 4. And initially, we are going to have 2 coastal water quality buoys which is equipped fully with BGC. In addition to the physical, we do not have marine meteorological observations on these coastal water quality buoys. And during this year, we are going to set up one of Vizag and other one is of Kochi. Probably, I think if Anish is there, my colleague probably can add some more. So we're going to have a suite of physical biogeochemical parameters from these two buoys. When I said about, we are talking about ship-based, but I'm coming to the, I just mentioned about the mode buoy. But once we have these buoys in place, we are going to have bi-monthly ship-based observations to calibrate and validate these sensors on water quality buoys. Probably that is an opportunity for us if we want to add any additional parameters, any additional observations on these things. So these two are basically the ship-based, but then I have the mode systems as well as HF radar network, and then we have this coastal current meter mooring array, which is being implemented through National Institute of Oceanography as part of our research project. So probably I can mention, provide more details, the point number 5, bottom-mounted ADCP and HF radars. So that's it from my side.
So if Venkat or Dr. Murthy are here, Venkat, can you hear us? I thought I saw him in the room, so
Amit, can I interrupt you? Probably if Anish has got any point to add.
Please. Yes, please. Anish, go ahead.
No, actually, I think Patavi has briefed. So basically, there are coastal ADCP, AWS, and water quality buoys. So these are the three coastal observations we are actually planning. We are going to sustain for next 5 years. So nothing else to add. And in addition to that, we also have plans to have coastal cruises. So we started it year before last year. Last year we couldn't do it because of the COVID restrictions. So we have planned to start from the Chennai till Paradip or slightly north of Paradip. So every season we are planning to have one coastal cruise, mostly measuring physical and biogeochemical parameters.
Can I ask how far from the coast these water quality buoys are?
Yeah, so these water quality buoys are at a depth of 30 meters water depth. So it is just at the edge of the slope. So mostly in Visakhapatnam, it will be around 20 kilometers from the coast and around 15 kilometers from Kochi. So this is our initial deployment locations.
Thank you.
So you don't have this Devashish, you don't have MET sensors, even 1 or 2 MET sensors on these buoys?
No, actually, the main objective of these observatories was biogeochemical parameters. So right now there are 19 parameters we have added into that. So because of the constraint with the design, we couldn't add additional sensors, MET sensors for the buoy.
All right.
You mentioned ADCPs. Is that in the same locations as these coastal buoys, or where are they?
Actually, there are all the locations where we are planning for the water quality buoys. Also, ADCPs are also there. And one more thing I forgot to mention, in addition to that, we also have wave rider buoys deployed at 16 locations, and those are also co-located with the ADCP moorings. So if you want, I can just share my screen to show the locations.
Yeah, sure. I'll just stop sharing my screen.
Yeah. Is it visible?
Yes, we can see it now, Manish.
Yeah, so probably Eric must have already seen this one. This was presented during RSC. So these are the locations of the coastal ADCP moorings. So there are 17 and 7 in the slope and 6 in the slope and shelf regions. So these are the locations of the coastal ADCP, and these are the locations of the water quality buoys. So at present, in the first phase, we are planning for the Vishakhapatnam and the Kochi here, and the second phase, we will go for the Goa and Veraval, that is one west coast we want to cover. And if we have sufficient funds, then we can go for Chennai. In fact, the NCCR has already deployed the water quality buoy here. So Chennai is already covered. So we are complementing NCCR and INCOIS to get maximum coverage. So this is the location of water quality buoy. And if it is visible, then these are the locations of the wave rider buoy network. So there are altogether 15 along Indian mainland and the island, and one is at the Seychelles. So more or less all these three network, wave rider buoy, ADCP, and water quality buoy, they are co-located. So wave rider buoy is at the depth of 10 to 15 meters of water depth, and water quality buoy will be at the depth of 30 meters water depth. So roughly 5 to 6 kilometers apart.
Anish, you can go to AWS. We can see the coverage,
Yeah.
the coastal areas.
Yeah, so this is the coverage of AWS mounted on the research vessels.
Here we have the full suite of marine meteorological sensors.
So I can share the details probably with the location and the what is the data set available so far.
Anish, I have another question. So, and Patavi also. These are probably the BG sensors, the moorings you're putting in. They're probably protected locations of some kind. So someday in future, you could put a standalone net buoy next to it.
We can think of, but as I mentioned, we have a lot of plans, but we have budget limitations and all. If budget permits, probably we can think.
And this figure in between, in fact, is the cruises we conducted last year. So we had plans to go with this sampling every season. So last year we couldn't do it because of the COVID restriction, but these locations we will be covering mostly in every season.
Very nice.
And typically, how long are these bi-monthly cruises?
These cruises will be only seasonal. Bi-monthly will be at each location where we are going to deploy the observatory, because all this observatory is mostly sensor based and one sensor is on wet chemistry. So this we will sample every 15 days or every fortnight to ensure the quality of the sensor. So we also have purchased one additional sensor. So if there is any large deviation between the in situ measurement water sample analyzed parameters and sensor parameters, then we will be replacing it with other sensors. So there is one set is always at the standby. So the bi-monthly sampling only will be at a buoy deployed location.
Okay, thank you.
Anish, is a lot of the data sent back to the lab in real time for these two coastal stations that you talked about, or that's upon the retrieval?
No, actually, this has an real-time transmission through INSET, and but it will the transmission frequency will be after every 1 hour, but the data acquisition is maybe every minute, except for the wet chemistry based sensor. Otherwise, it is every minute acquisition. And we have two types of transmission. One is through HF. So at the shore station, the data will receive every minute, but through satellite, the data will be transmitted every 1 hour. So at real time, we will get the data.
Thank you. So I know Neeraj is in the audience. Neeraj, did you have any comments on specific analysis going on for the coastal processes at SAC?
Yeah.
Coastal.
Actually, there is this Sentinel SAR is there, and RISAT is there, which we are currently in the process of analyzing. The coastal regions of the Bay of Bengal for getting signatures of the internal waves, and we are getting some interesting results there, especially near the Chilka region. We are getting signatures of the internal waves, and also in the North Bay of Bengal region, apart from the Andaman Sea region. So this is one thing that this high resolution synthetic aperture radar images can be used to get the signatures of the internal waves. Then another opportunity that is going to come in next 1 year is basically the SWOT mission, the Surface Water Ocean Topography mission, where the very high resolution and very near to the coast, up to 2 kilometer near to the coast, we will be able to get the synoptic view of the dynamic topography, basically the sea level field. So it will be having a swath of 60 kilometer on either side, and this is going to be the first time that you will be seeing the sea surface height at that high resolution and a synoptic coverage, unlike the previous Nadir altimeters, where we used to get the sea level observation along the track or the line, basically. So these are, and then of course, OceanSat 3 mission, which will be providing the high resolution sea surface temperature observations, as well as the ocean color monitor at 360 meter resolution. So of course the scatterometer on board that. So these are some of the observations that are going to come in next 1 year. And then we are also actually working on the projection of the sea level to coast. Basically, the problem with the sea level data currently is that we don't have the high resolution sea level data near the coast available. So we are employing certain empirical and dynamical techniques to get the sea level anomaly data near the coast as well.
Yeah, I wanted to bring the discussion back and ask sort of my fellow attendees here, including Eric, about dye release experiments in the coastal areas. So Jonathan, Jen, Eric, I'm not aware of any dye release experiments that have been done in the Indian coastal region. So any comments on that would be welcome from the Indian participants as well.
I'm going to sort of answer the question. Neeraj was just talking about sea surface height measurements from these new satellites, and I was wondering whether or not sea surface height could be measured from the autonomous aircraft, that might be a really nice synergy, particularly if you're worried about how to get them from offshore to the coast. If you fly from offshore to the coast, then you could do that. Would require a ranging radar or LiDAR and a really good GPS on the vehicle. That doesn't seem impossible. Dye releases can certainly be done. Maybe somebody else has something else to say about that.
So Mani, are there plans for
Yeah.
the kinds of sensors that Eric just talked about for the UAV program at IIT Madras?
Yeah, so there is already GPS on board. LiDAR is something that we are exploring. It is something, so right now we are at the testing stages of the UAV, and we have a visible range imaging system, and we immediately plan to also have an infrared sensor on board. But LiDAR is something that we would like to go towards, and we have talked quite a few times about dye release experiments as well. So I don't know if Bharat or Murthy, do you want to add something? If you're available in the room.
Mani, meanwhile, I can ask one question.
Yeah.
Yeah, sorry to interrupt. In fact, we are looking for such observations from the autonomous vehicles, particularly the drones and all. So in fact, we need, in addition to the visible, whatever you have mentioned, IR, and also actually we are, as you know that now we are giving oil spill advisories. So if there are any such events, probably we need to have some drone-based observations, particularly SAR or something is there, that would be good.
Okay, sure.
And also we are issuing another service, harmful algal bloom services. If there are any such events are reported, probably we need to have observations from these drones, equipped with the right kind of sensors.
So essentially,
that is where we have planned. We have planned in next 5 years because of budget restrictions and all. Then again, one drone with the required sensors. But probably that, if you can cover, that will be good.
So we on a related note, we are also going to have studies in analyzing satellite currents or other model output currents in understanding transport on the ocean surface. So that could also be relevant for these oil spill or pollutant spread advisories.
Advisories, we have a model set up and we have been providing the advisories, but only for validation and all. We need, actually at present, we do not have surveillance system, and whatever the satellite observations, the repetitive period is not matching with the requirements. Probably if there are any such events are happening, and if we get some report on those things, probably we should be immediately able to put these observing systems in place.
Sure. So then I had a question with regards to dye release to Eric and other experts who have experience running such experiments. So over what scales would it be most useful to perform these dye release experiments? And is it realistic to think about estimating diffusivities from such experiments? Do you have comments on that?
I think the answer is yes, you can do that. Timescales should probably start at hours, minutes to hours, and work up as you get better at finding the dye. The biggest issue, one of the bigger issues, is that the dye disperses, and therefore you could see pretty soon you can't see it anymore. So and you can lose it. All these practical issues come into play. It's also important what the depth distribution of the dye is, because what you can see from this, in other words, it can spread out sideways, which you can see from the surface, which is really hard to do other ways accurately, but it can also spread out vertically. So it might be a good idea to do both at the same time. It's also a good way to it's very easy to lose dye from a ship. So having having an overhead vehicle that tells you where tells the ship where to go to find the dye is would be a good combination. But I'd start out in the morning, figure you're going to be done by the end of the day, and then work up from that.
Okay. So there are a few comments in the chat box.
Yes, I wanted to invite Jen. Jen emphasized the point that Eric just made also, and she mentioned a coastal mixing and optics experiment that she was a part of. And there's a reference that she's posted on online in the chat window. Jen?
Yeah, no, that's it. I was thinking similarly to Eric, and there were a couple other
Sorry, I don't know if it's me, but on my screen, Jen is frozen.
Yeah.
I'll just type.
Yeah, I can't hear
Jen
her
was
either.
frozen. I don't know what she was saying, but I guess I was going to add one thing about dye dispersion on some examples from the Oregon coast in like the stronger upwelling systems. The dye can disperse really, really quickly. And so I think some of the challenges that Eric mentioned are kind of real. And so having the sort of the complements of like the aerial and the shipboard, I think are important for those sorts of things.
Eric, Debashish here. Can I remind you of a couple of discussions? Canvas shoes filled with water, and we were thinking of GPS. But if you have a drone to look at those things from above, canvas shoes with an LED that works in the water, then you can do hundreds of those, maybe. Easier to track. Does it give any useful science results? Those little things.
Yeah, we did a lot of work on that in the Gulf of Mexico. Bamboo dinner plates work really well. Just dinner plates, they're about 30 centimeters, a little more than that wide. The bamboo biodegrades. You can get them for less, for hundreds for dollars. And you throw them out and you can see them really well. So that would be, and they stay on the surface, so you don't have to worry about them going down.
You were seeing them from where, Eric?
From a drone.
All right, that sounds good.
So look up under Carth, C-A-R-T-H-E. There's quite a number in it. That was what bamboo plates seem to be the best. We contemplated oranges and grapefruits and mangoes and things like that. They all are slightly lighter than water, but it seemed like having a large number of rotting fruit on your boat would not be so good.
How about banana plates, Eric? Banana leaves are used quite a lot in India for making these.
Yeah, that would probably work well too. Anything of that size, you need, and if you have a really good camera, then you can actually watch the plates or whatever they are. Banana leaves would work fine, spread apart. And there's a lot of interesting, useful information in that.
And Eric, you said such an experiment was tried out in the Gulf of Mexico?
Yes. Yes. Just if you can't find it, ask me.
Okay.
Can I just ask a question? I don't know if we're going to get to that or not, but I was asking Craig about gliders and whether there are options for, glider type vehicles. And I guess the thing I was thinking about was on the Oregon coast. Again, we have sort of a series of moorings to give us a cross-shore perspective of the flow, and so getting that cross-shelf distribution can be really helpful. And I guess I wondered if there are any ways or plans about thinking about getting those sorts of observations, or what kinds of things could be done at a particular site or like a couple of locations that were like intensive observational sites.
We have a regional example of those two lines have been occupied off of Sri Lanka for some time now, what that might look like. Patabi had said there'd been some progress on the ability to operate Iridium within the EZ.
Greg, can you repeat?
Well, I recall last week you'd said there'd been maybe some progress on your ability to run Iridium equipped vehicles inside of the EZ.
Yes, we have. Yeah, but we cannot transmit in real time. We are working on how best we can use these gliders now for coastal observations. We have to come up with a SOP. We are working on it.
I mean, that would be a beautiful application of those gliders.
Yeah, but only
choose
thing we
the
cannot
lines.
transmit in real time. We have to find alternative ways.
Right.
Yeah, we are working on that. Definitely, I need your help. I'll get back to you. Yeah, I think Amit was asking about the buoys with marine meteorological sensors. I thought Venkatesh will brief about more buoys. Is Venkat there? If not, then probably I can add.
Yeah, I saw him a while ago, but I'm not seeing him.
Yeah. In addition to the mood buoy network, what we have shown last week, open ocean mood buoy network, which is called Omni buoy network. And Venkat is also maintaining few coastal buoys, fully equipped with marine meteorological sensors. We have about, I think, 3 coastal buoys. And then one Calwal site in Lakshadweep Island. That is mainly NIOT. Venkatesh is working with SAC mainly for the calibration and validation of the satellite sensors. These are mood buoys from the Omni network, which Dr. Venkatesh is maintaining. And the data is coming in real time to INCOIS, and then we exchange it for research purposes with the users.
Simi has a question in the chat box asking, are there plans of deploying drifters as part of studying the coastal currents in INCOIS's 5-year plan?
Yes, Amit, we have plans for deployment of 50 per year, but again, we have reduced it to 20 per year. Maybe we have plans to deploy few of them in the coastal waters. The number is not yet decided, but it all depends on our modeling group's requirement. If they need any controlled experiments, probably we would like to take that and then get the sufficient number of these drifters in the coastal waters.
Okay, thank you, Patavi sir.
What about autonomous surface vehicles? I know Jonathan and if Venkat is still here, there was an example shown of NIOT's vehicle, and Jonathan has done similar studies in some very challenging environments. Are there plans to have autonomous surface vehicles too for such observations?
Venkat's group?
Yes.
I mean, yeah, I'm not sure. I think Venkat has some program, but probably somebody from Venkat's group here.
Yeah, they have not planned anything. Dr. Josia was planning.
Yeah.
I will get back to you from Josia.
And I guess one thing that that I would add is that we have, we've changed over from using autonomous kayaks to autonomous rigid hull inflatable boats that use just standard outboard motors and Garmin navigation systems. And I'm really, would be happy to work with folks to extend that technology to a group there if that was something that was of interest. We still also use Iridium for communications, but they can also be used with radio frequency as well. So.
Thanks, Jonathan. We have a rubber boat Gemini craft. I've seen your new design. We'll take your help to modify that. Thank you.
So one of the places where I thought the center could really work well, Mani, was there sort of sounds like there are many different plans, and bringing it together for some focused questions or around either in time or space, as Eric mentioned, focusing on a couple of geographical areas of the East Coast.
So what we already did some measurements in 2019 of Paradeep. It's also a region. This was with scientists from INCOIS along with the OMM program, and for both internal tides and coast wind generated near inertial activity, that region is supposed to be quite strong. So in that sense, I do think the coastal region of Paradeep is quite interesting scientifically. But then in terms of ease of operation, the coast of Chennai is also attractive. So maybe we could identify Chennai or Vizag and Paradeep as two specific locations around which we could work.
Probably here, Mani, you can see that now you can identify the hotspot, and probably have to see that. See, most of the observing systems, whatever we have mentioned, the coastal things. Now we try to have at certain locations. Suppose we are trying to align our some of the observations, matching with the coastal radars and wave radar buoys together, or now like whatever Nisha has mentioned, water quality buoys. So and then some of our wave radar buoys are in the locations where we have this LADCP coastal ADCP network. So probably you have to see the distribution, and then probably you can. So these things will supplement your the planned observations.
Sure. So I will.
And also we should the most important point which I would like to convey here. Say we do have earlier certain overlapping among our labs. Now in the 5-year plan, now we try that. We are very sure that we will not duplicate other efforts. Now we have to make sure that there is no overlapping. So we try to probably supplement or complement each other in achieving the objectives. That we have to keep it in our mind. Yeah.
So Mani, we are about 50 minutes past the hour.
Yeah.
We started.
So
you want to move to the next topic?
Yeah, surely, Amit. Thank you.
Amit, can I interrupt here?
Yes, please.
The last point is most important point, EZ constraints.
Yes.
So we have restrictions, particularly when it comes to the coastal waters, and in particular, if it is in the territorial waters, there are a lot of restrictions. Probably when we plan these experiments, we have to adhere to those guidelines. And particularly when it comes to the exchange of data with foreign, that there will be some, but it's not that all. There are certain parameters which are completely restricted. So that point we need to consider when we plan this. Whatever.
Dr. Patabi, you need to keep in mind the interest of DNAM and which they have been writing to us.
Yes, that's why I mentioned the last point.
Because the biogeochemical also, they wanted us to write to them that what we are measuring. That particular time, we told them that we don't have plan.
Yeah.
So that is also getting evolved, their approval procedures and plan. Please coordinate and.
Yes,
That's
yes,
the question.
definitely, definitely. Yeah, we have checked the parameters list and all. That's fine, I think. But anyway, we'll look into that.
Okay, so maybe Amit and Eric, can I move on to the next topic?
Sure.
Please.
Yeah. So I thought we would spend a few minutes on talking about large-scale modeling efforts. There are some ongoing interactions we have with NCMR WF and Anish at Colorado, doing some sensitivity studies on large-scale models. So maybe we could identify more specific topics on which we could collaborate. And it's quite relevant here that some of my colleagues at IIT Madras last week spoke about their work on handling large data sets, improving parameterizations for turbulence modeling. And there's also some ongoing work on incorporating machine learning, physics-based machine learning to improve turbulence models in some fundamental flows. So some of those ideas could be quite relevant as well. So maybe can I ask Anish and Dr. Ashish at NCMR to comment on this topic?
Yes, Anish first.
Go ahead.
I'll go second. Yeah.
Okay, sure. Yeah, I was going to say that, sorry, many of the teams under GFL can contribute to this effort. Like Dr. Ashish presented last week about their effort at NCMR WF with both regional high resolution models, but also the global models to do experiments on what scales of SST matter for monsoon prediction, and then what governs those SST evolutions, right? And here we also are studying the same. We have looked at a global model with ocean data assimilation and without ocean data assimilation to understand what's the role of subsurface ocean data in initialization of forecasts of monsoon. We also have like a regional high resolution model where we can do sensitivity experiments to understand how this different scales of motion would impact SST evolution, and then further, how does that impact ocean atmosphere interactions. So I think the second point in terms of data sets, parameterizations, and machine learning, there were really good talks last week about how to tackle this from observations as well as modeling data sets, but then feeding that back into model development and how do we develop our coupled models to improve monsoon prediction. That's something we can discuss as a group in terms of establishing collaborations to either, if there is like a parameterization that is developed, how do we test that in our regional and global models? But also, how do we develop experiments with our regional or high resolution models that can complement the development of parameterization? So there can be a two-way interaction. And the same with machine learning also, right? Dynamical, I think Balaji spoke about dynamical or physics constrained machine learning, which is important, I think, in our field of not running machine learning as a blind tool, but constraining them with the known physics in our systems. So having a good interaction between the machine learning group and the dynamical modeling group would help facilitate that. I'll stop there, Mani, and yeah, listen to Dr. Ashish's presentation.
Yeah, thanks, Anish. Dr. Ashish.
Yeah, thanks very much. What we saw presentations in last 2 days was really very nice, because it's a combination of very small scale to process studies, then going to the basin scale. So this is ideally, if we collaborate and stick to this program, I think over the years we can progress. And additionally, these observations we are talking about is really exciting. So we are now at a time like our INCOIS colleagues are there for services, they are using this model for prediction. But now we are in a time we can say that the structure, both horizontal and vertical structure of salinity SST, we can start verifying at least in the mesoscale, sub-mesoscale or the eddies. Both I'm suggesting horizontal and vertical. Although there are very few observations, particularly in the Bay of Bengal, but whatever observations are available, we start verifying. And one thing, say, I am also from oceanography background, but last 30 years I have been working in NWP, weather forecast. So what 20, 30 years back was this weather forecast models. I think today in terms of ocean forecast, in terms of verifying the processes and the structures, we are at that point, but things are much better. So what I propose that starting from mesoscale to sub-mesoscale or eddies, we make it a regular process to verify those things. Like, let's say we have daily forecasts, ocean forecast of temperature, salinity, and currents, and whatever observations we have from the assimilation system, start verifying. Then when we start looking at them, we'll see the deficiencies and then start looking at the small scale observations we are talking about, special observation and new observations we are going to put. And it's going to be really interesting. So we start and get going to study some processes or some particular features with whatever model output and observations we have. So we can fine tune all this thing, and this Bay of Bengal will be very interesting because, you know, there is water mass coming from the Arabian Sea, then from the equator, then fresh water coming through the rivers, and the tide, how the tide currents, they are interacting non-linearly, the density driven current. So Bay of Bengal will be the ideal place to take up and making a project of the circulation, temperature, salinity structures, and validating them. And we can think of a high resolution reanalysis also. So we have a lot of observation from NIO and from INCOIS, and many of the past observations maybe from which are restricted may be available. So if we can do a reanalysis high resolution for the Bay of Bengal, it could be a very good idea, and it will be idealized observation for validating the model. So with that, I'll stop here. Thank you.
Thank you, Dr. Ashish. Does anyone else have any comments or inputs? So, Dr. Ashish and Anish, we will continue our interactions after the meeting.
Yeah, sure.
Yeah. Do other people in the
may I add a point here?
Yes, Neeraj, please.
Yeah. In this regard, you see, one of the outcomes that can come from these type of large scale modeling or sensitivity study is to basically define even the space sensors for the future. What kind of observing systems you require from space, what kind of spatio-temporal resolution, OSSE kind of experiments can also be, aimed for, defining better future sensors.
Yes.
Thank you, Neeraj.
Manik, may I add one point here?
Yeah, please.
Yeah, I think you can include Dr. Francis. I asked him to join this session, who is looking after this modeling activities at INCOIS is with my group. Okay. So probably you can include him along with you and Ashish and Anish.
Sure. Are there any other comments?
Maybe one quick comment.
Yes,
I think in terms of organizing this effort, there are different parts to it, right? There's one where it's the high resolution regional model, then there's the global modeling effort, but then there's also the observing simulation effort as well as the data assimilation effort. So maybe we can think about how to organize these in these different tasks, and then how each of those groups would interact as well.
Yeah, sure. That's a good point, Anish. Thank you.
Thanks.
Okay, if there are...
Mani, I have one question, Mani.
Yes, Samin.
With these large data sets that's coming up from observations and experiments and simulations, is there a coordinated effort to put it somewhere so that everybody can access and make the data set for their own purpose?
So we can...
Not publicly, at least.
Mani, may I add here?
Yes, please.
Mani Patabi here.
Yeah, please go ahead.
Yeah. I think INCOIS has been designated as the National Oceanographic Data Center. And we are receiving the data from all the observing network, whatever I have mentioned in the just before this session. All the data is coming in real time, as well as the data which is collected by various institutes in the country. Majority of the data has been deposited with INCOIS, and we are using it for our operational activities, particularly in modeling. And all these data is collected at a National Oceanographic Data Center at INCOIS. The past data as well as the data that is coming in real time.
So how accessible is this data? Is it?
Most of the data sets are available through our live access server. If there are any specific requests, no, we are providing based on the request we're providing to the users. And mostly the gridded data, like Argo data products, 10 days and monthly products, and then our GODAS analysis products are available on live access server at INCOIS. And if you want to use it directly, you can use OpenDAP. We are also having the AirDAP facility, if any modelers they would like to use. And also the data from all these systems, which are like Argo floats, gets into the global telecommunication system, and it is available on GTS. And if there are any specific data set, then probably you can send us a request, and data center will provide the data.
Okay, so you are the nodal point so that we can get the
Yes, INCOIS is the nodal point for oceanographic data in the country.
I see. Okay.
Yeah. Okay. Thank you. So there were a couple of quick comments in the chat box on the previous topic. Amala Mahadevan had said that we could organize some of our field activity or the day release or drifter studies around HF radar observations. I think that's a very useful input. We'll surely do that. And Aditya has shared a link for the coastal altimeter dataset. Yeah, thanks, Aditya. So we would like to spend a little bit of time on some of these fine scale process studies we would like to do, which ranges a combination of theory, simulations, and experiments. So I would like to invite Anubhav to lead this discussion. Before that, can I also request Thierry Doxwa to say a few words about his observations from last week, and if he has any input on this initiative?
Okay, good morning, good evening, Mani, and to everybody. Yes, so I visited Chennai, and more precisely IIT Madras in January 2020, just before the pandemic started. And it was for me a very useful visit, and I should add, very friendly. During my visit, I met several very interesting scientists over there. Well, I knew you, Mani, very well, and it was a pleasure to meet you again. But I met also your colleagues, Anubhav and Samin, and some others, and we had very interesting discussions. I should say that we also ran together the Chennai Marathon, a race that started at 4 a.m. in the middle of the night. So be careful, if you accept to go to Chennai, they will bring you to the race. No, more seriously, there is a lot of very interesting senior people to do science, and also many students, and often very smart. I had a very interesting discussion, and I think it's also very important to set up such a center. So this is why I think starting this collaboration, starting this Geophysical Flows Center is excellent. Mani and your colleagues, Anubab and Samin and others are trying to, what I liked is that you are trying to develop a center using numerical simulation, using theoretical understanding, using field experiment, using lab experiments all together. And I think it's the way we will reach more easily the understanding of the question we have in our mind. So I think definitely starting such an initiative is very useful and timely. So this is maybe, and maybe I forgot to say that in addition, at IMT Madras, there are a lot of visitors. I met Eric Dassaro for the first time over there, and we had very interesting discussions about, in particular, I remember one about a long one about the spectrum of internal waves in the ocean and how can we believe the results, to simplify. So I think I'm very excited to be part of this group of people interacting for such a center.
Thank you very much, Thierry. Yeah, so we would very much look forward to the interactions too. So, and thanks for ignoring the details about who ran what distances in the marathon. So, Anubhav, can I just request you to get started on the discussion on fine scale processes?
Sure, Mani. Hi, everyone. So this is a continuity of what we were discussing previously. Now, we had talks last week, especially we had on 7th Amit speaking about sub-mesoscale processes, and especially the theme going on from 7th and also on 8th, where there were a set of talks, Amit, Sutanu, Samin, talking about different turbulence numerical calculations for stratified rotating problems. So I think from that point of view, this group has a strong expertise on doing different numerical calculations, especially for the sub-mesoscale and the dissipative scale problems. What I think we have to think about is trying to make it, connect it to observations that probably are relevant to the coast of India. That's what the starting point was, and see how some of these can be made specific to the geographical location. In terms of the problems that we are looking at, even going further down. So the problems that Housam spoke about, one of them which is quite relevant, that's regarding the coastal erosion problem. He discussed it in the beginning, that how erosion actually takes place in the coast, and a study of that kind would really benefit from observation. So the exact example that he had in mind was from the western coast of India, which is how the mangrove forest actually kind of have an interplay with the erosion process. So again, so there is a good number of theoretical studies, numerical simulations, and also lab experiments. Thierry, Louis, Andrea, they all spoke about different aspects of internal wave experiments, mixing in stratified turbulence. So the goal for most of these fine scale studies would be to see how we draw in the connection to observations. And I think if we are able to try something of that sort, that would be really tapping on the strength of the group who is doing these numerical calculations and laboratory experiments. So Samin, Housam, Sutanu, if you guys are around, if you want to add something.
Yeah, Anubhav. Yeah, it was.
Yeah,
so the kind of problems, the variety of problems that was presented last week was quite, I would say, wide spectrum, and to divide this into few pieces like what Mani has done, the fine scale process, to be precise. Yeah, that is something that I look forward to see in the group, especially the large simulation data sets to go complement with the observational data that the other, the large scale process group has been, saying it a few minutes back. So if there is a link, if, at present, if you look at any of the literature, the large scale process stays separately, fine scale process and the theories stay at a different plane. There is, I don't see, a link between this fine scale process and large scale process very often. It's, I think it is in its infancy. So probably this is a, the center could act as a catalyst to that, to connect the large scale process and the fine scale process. And if the group can come up with something, I think that is going to be a fantastic result from that. That's all from me, Anubhav.
Thanks, Sumit.
Yeah, so I would.
Hello, everyone. Can you hear me?
Yeah, please go ahead.
Go ahead.
Okay. So thank you, Anubhav, for summarizing this. I just wanted to add that we can always do some kind of theory or some simulations, but at the end of the day, what really gives credibility to the work is having that comparison with experiments. So if there is the ability to do some of these highly detailed experiments with fancy optical diagnostics, we can also tune our numerical and theoretical work to be able to match with the experiments. And I think there is a lot of value in doing that.
Yes, I think that's a good point. Yes, see, in the 90s, if you look at it, the CFD was catching up with experiments. The purpose of CFD was just to validate the experimental data. But now, in this century, in the last, 15 years or so, the situation has completely changed. Computation can have its own standing. It can come up with new theories, new mechanisms, and that has to be tested by observation or by fine scale experiments, as he has said. So that again, if somebody is doing lab experiment, the theories that is generated from CFD can be tested, one-to-one mapping. Unlike, you see the literature and try to map, we have the raw data here. Getting raw data is always a problem. So we have a raw data which can be shared, and then you come up with a similar set of experiments. That would be great. Yeah. Yes.
Yeah, so if I could add, yeah, one of our real goals, we spoke about this a lot at an individual level, that if we can motivate some of our fundamental studies from the real world, that would be quite useful. And we are in a unique position where we have close interactions with people who do field campaigns, all the way down to people who do fundamental studies, which in one perspective can be seen as quite wide in scope. But I think if we can, for example, in the beginning of this discussion, we identify the geography and the specific problems we are after, and organize some of our studies around the real world phenomena, that would be really useful, I think. And the fact that, yeah, we have this new technology component, which is the development of unmanned aerial systems, makes it really exciting for my aerospace engineering colleagues as well. So yeah, and one of the purposes of having this meeting was to essentially for everyone to see each other. I think more of these meetings will develop an overall appreciation for all of us of how to connect these different components. Is there any other comment? Is there something you want to add, Anubhav, or anyone else in the audience?
No, I think that's pretty much it for this. I guess, I mean, just as an example, Thierry showed this in his talk, where he was talking about the laboratory experiments on the internal wave resonances from Dheeraj's and your study. So that's like, again, a typical example of trying to do things which the numerical expertise can tap onto what experiments can do. And then if the ideal thing would be taking it forward to measurements that come up from the field.
Mm-hmm.
I may add a few words. You hear me?
Yeah, Louis.
Yeah.
Okay. Yeah, I totally agree with what has been said on what can bring lab experiments to this study. And just to add something else, what's also interesting is that for some specific measurements that you want to do in the field, specifically the ones from aerial measurements, there can also be an interesting input from our experience in the lab, because many of the techniques like pattern recognition, image processing, PIV from these images is also what we can do and test in the lab at smaller scale. So I guess it can be a good combination between a good exchange of knowledge and practices from our two communities. Mm-hmm. So that's it's also the case for multi-phase flow and air-sea interactions. These are things which are really small scale and can be studied with similar equipments in the lab. So this is maybe a way of collaboration between our fields.
Mm-hmm. Thank you, Louis. So is there anything you would like to add about the field measurements? Because Louis, I know you have quite a lot of experience going in the ocean as well.
No, that's it's quite exciting because for my part, I don't know much about this specific region. I haven't studied yet, so I'm reading some literature on it and exciting to know more. Somebody mentioned activities, evidence of internal solitary waves by SAR images. Mm-hmm. I guess it was probably in the northern part of the bay.
Yes.
For what I've seen. Here again, something that can be really interesting, because SAR images are fixed in time, mm-hmm. but to have a combination between when you know the time of passage of a SAR satellite, and then combine the passage of the satellite with in situ observation with aerial equipment that you have, maybe infrared or LIDAR, as you mentioned, it can be really interesting to do.
Mm-hmm. So I think that was Neeraj from Space Application Center who mentioned about the SAR images revealing internal wave activity. He will surely talk more about it.
Okay.
Yeah. So is there more points to add on experimental modeling from Louis or Thierry or other people in the audience?
Yes, Mania, I have maybe a question to ask to people who are doing real oceanography, if I may. Personally, I like the idea to tackle the different questions discussed today and the 2 previous days. With on one side, oceanographers who are doing field experiment. And in parallel, people like Louis, myself, and several others using lab experiment or numerical simulations who are interested by simplest questions or physical mechanisms and not more difficult oceanographic processes that definitely combine different processes. So I think, I personally believe that this approach is useful, as it was for biophysics, in which first biologists were contributed, and then physicists in relation with biologists came into the play. And I think both together they achieved very interesting goals. I think this is more or less what Ashish Mitra from NCMWF said earlier, so 30 minutes ago. I never met him, but I think this is what he understood actually from what he said. And I would be very interested to discuss with oceanographers, either today or later in Madras, in Chennai, on how large you believe in this approach, doing lab experiment in tank 1 meter deep with a lot of dissipation. Do you believe, or it's just for fun, you think?
So if there are is someone who would like to comment, that would be, it's a very interesting question.
Can I just add a comment? See, I'm not experienced in this lab experiments, but I've observed them closely. Like I was working with Professor Krishnamurthy and his wife, Ruby Krishnamurthy, used to do a lot of lab simulations, and she used to publish these papers. And there were so many similarities with real world. So something called scaling. So they will simulate in the lab and scale it mathematically. And certain things can be verified using real observation and model. So I'm sure you all know those things. So that's one area maybe in this group we have to collaborate and see how from lab to real observation in the ocean and the large scale field from the model, what we can compare, what we cannot compare. So some of those listing have to be done. Thank you.
Ashish mentioned Ruby, so I was reminded she was trying to make a model of the Bay of Bengal in the lab with a river entering at one end, and she was asking the question, how does it leave? How does the river water leave? It's a wedge shaped. I don't know if she completed those experiments, but it's a question the experimenters can think about.
Are there other comments or inputs? I hope we'll have plenty more time and opportunity to discuss some of these points. And whenever in-person visits are possible, I'm sure this would make for very interesting discussions. Would you like to add anything, Thierry?
I think it's okay. Maybe it was difficult to reply to my question with the public, last public, but if anybody would like to send me a message, I would be very interested to get any answer, even if it is a negative one. No problem with it. I think it's important for us to exchange about that point also.
Yeah, I would like to be part of that discussion too. I am very curious to know.
But this is a similar question that is happening with the industry problems and the academia problems. Exactly the essence is the same. You pose a problem in academia in experiments, and how close is it to reality in the device that especially for aerospace, say if it's rocketry, how is it close to the real world? So it's exactly the same question, and the way Thierry posted, he asked the question, and then he was laughing. so the answer he expected is something different that does not come out.
So I'll say something. There's the real world is really complicated, and one approach that the people are using a lot recently, you all know this, is to run models which are not quite as complicated but are still extremely complicated. And it's really easy to get lost in that and focus on lots of phenomenological things which maybe are just due to either issues with your measurements or issues with your numerical things that aren't quite right. So I'm answering Derry's question in a slightly different way. The question is, what's the role of theory, which has many tools to work with? And it's really important, because sometimes you need to think about the fundamental issues. And that's, I think, where this sort of work comes in. You don't do a laboratory experiment of the entire Bay of Bengal. That's not going to work very well. But you can use that to highlight specific processes that aren't being modeled correctly because the model hasn't got the scales or something. I mean, a good example of that are high frequency gravity waves, which are non-hydrostatic, which most large scale models are hydrostatic. You can't get the physics right, and particularly in like the Andaman Sea can have pretty significant transports. And so I think that's where the communication is important between modeling and theory, and people like Terry who have the real basic physics background and the observations. The whole program's much richer, and it's going to avoid fundamental mistakes when you have those sort of considerations. And that's sort of bland, but I think it's really true that it makes everything better, and it keeps things on the right track.
Thank you, Eric.
Thank you, Eric.
I wasn't specific, because if you were really, the whole point here is to find out what you should be specific about. But that's hard. That's hard. Getting the questions a much harder problem than solving it.
There are, on the scientific side too, Eric, there have been some topics where theory and observations and experiments have come together. I'm thinking of wave mean flow interaction, for example. That means different things to different people. But that has a very practical connections. Going back to the theory from calculating the Stokes drift from the surface wave field, looking at its impact on the upper ocean in terms of Langmuir cells. Eric and many other people on the room have done lots of work on that. That has a rich history of theory, as well as people trying to do lab experiments related to that. Going way back at Woods Hole and other places.
And on a much larger, sort of on a much larger scale, and I talked about internet on a much larger scale, that when you think of these old ideas about, they've been around for many decades, of Rossby, long-range Rossby wave propagation. That's something which can be modeled quite simply, and I'm still sort of confused about it as to what the role of that is in the Bay of Bengal. But there's a lot of idealizations, and all of a sudden you say, oh, that's what's happening, and this is why or why not the operational complicated models get it right. And then that's very closely related to these ideas of how long it takes to set up gyres. I'm also very confused about that. In other words, how long, there's sort of in the monsoon season, there's sort of a gyre in the northern Bay of Bengal. I don't have a good understanding of how long would it take to set that up? Are we way faster than that, way slower than that? These are all simple ideas that I think help our understanding and help us build predictive models way better. And I'm just bullshitting, but there's lots of stuff like that which I think needs to be considered and will help us a lot.
and maybe Mani, if you allow me, just answering to what Samin said 2 minutes ago. It's another anecdote. When I was a master student, I wanted to do biophysics. It was I'm old, so it was the late 80s, and at that time biophysics was not fashion. Okay, so I came to a big professor biologist. He told me, you would like to do biophysics, stop physics and learn biology. And this is not the answer I was expecting. So I prefer what Eric and Amit just said. I think so. I think it's a different way to get to reach the point, and it has been proven that finally it was a successful for biophysics, at least successful way to help a biologist. So this is what I wanted to say. Just.
Thank you, Thierry, for introducing that thought-provoking topic. So maybe in the interest of time, we can continue these discussions later, hopefully in Chennai at some point in 2022. So I will conclude this discussion right now and spend maybe 10 or 15 minutes talking about some of the administrative details and further events that we are planning under this research initiative. I promise I won't take more than 10-15 minutes. And we'll conclude with Professor Murthy, who's the head of the Department of Aerospace Engineering, saying a few words before we close the meeting. Thanks everyone again for your participation in this discussion. I'm sure there are many other inputs that we didn't have time to discuss, but hopefully the further events will give us an opportunity to do the same. So Anubhav, can you confirm? I'm not sure if I'm sharing the right screen, so let me share again.
Yeah, we can see the screen.
Yeah, thank you. I'm just trying to go into full screen mode. Yeah, again, thanks everyone for your participation. It really means a lot to make our efforts more coherent. The first thing I wanted to say is we do plan to make a summary document from this meeting, the 2 days last week and today's discussion. So hopefully in a couple of weeks' time, we will be able to share such a document with you. Rest assured, we'll try our best to incorporate everyone's inputs. I would like to bring to your attention another event that's coming up later this month. This is IIT Madras's formal introduction to this research initiative. As the director mentioned in the first day, as a part of the Institute of Eminence framework, quite a few research initiatives have been approved and they have started, much like Geophysical Flows Lab. This is going to be a 30 minutes event on September 28th. And the timing is, we have fixed the timing so that it's convenient for people joining us from Europe and the US. I would really like everyone to participate if your schedule allows. It would be quite nice. So the event is organized as 15 minutes of presentation from me or some of my colleagues. We'll try and summarize what the goals of the initiative is from the original proposal and what we have learned from this meeting in the last 1 week. And there will also be 15 minutes of moderated discussion. This event is going to be open to the public, and Eric Desaro has kindly agreed to moderate this discussion. So please, if possible, put this down in your calendar. It would be nice, and all your research group scientists are also invited to attend this event. We are also planning a workshop bar meeting type event in January 2022. The COVID situation is still evolving, so ideally we would have preferred holding an in-person event. It's not clear if that is possible, but we are still discussing locally here. Maybe we will do a hybrid of an online meeting such as this one and an in-person meeting for those who are able to travel. And in these subsequent meetings, we will have lesser number of speakers and maybe slightly longer talks. I understand several of you did not have enough time to present. So that was the nature of this meeting. So, but I'm sure in the further meetings, we will have more time to present our ideas and results. There are a couple other events that I would like to bring your attention to. There is an approved meeting on waves, instabilities and mixing in rotating and stratified flows at the International Center for Theoretical Sciences, which many of us have been to as part of OMM ASIRI meetings. So this is organized together by Thierry Silva, myself, Philippe and Anubhav. So this is a confirmed meeting right now. It's planned to be held in person. But again, everything depends on how the COVID situation evolves. And assuming it's going to be an in-person meeting, we would like to follow up this meeting at ICTS with a GFL meeting at IIT Madras in the week following right after April 4 to 8. So again, if travel is possible, would request you to put these dates in your calendar. I think it would be quite interesting and relevant for all of us. And I'll keep in touch as we are able to decide on more details about these meetings. I shall certainly keep everyone informed. There is a website for this research initiative on IIT Madras's main website on its efforts under Institute of Eminence. So please do take a look. Give your comments on the material, or if you have any inputs or changes that you would like to propose, I'm happy to. We are continuously making modifications to improving this website. So please do take a look when you get a little bit of time. We have a newsletter planned to be released once in 2 months. This would be a semi-technical more popular science-like article. So we will have an editorial board, include various events of GFL, but also include write-ups that would be relevant for research in GFL, and also cover some specific research spotlights. Again, I will share the first few editions. We are just finalizing them by email. And your contributions are most welcome. Now, one, it would make the newsletter that much more interesting, and two, we are soon running out of material, so it would be really nice to hear your perspective on any of the topics we cover or some specific research that you would like to talk about. We have, I don't think this came out explicitly, we have a pilot cruise planned. We are finalizing the details in December 2021. We will also be testing our unmanned aerial systems in this, one of our first unmanned aerial system in this cruise. So we'll keep you posted regarding the same. Requesting you to acknowledge Geophysical Flows Lab in publications that result from our interactions. This is important for IIT Madras. And finally, this initiative really welcomes not just collaborations, but IIT Madras, the director has made it very clear. We would like to host in most, if not all, of the collaborators, both Indian and from abroad. And there are several modalities by which these visits could happen. So I would like, and I will present some of the details in the next slide. And if you are, and the more details we can happily discuss if you are interested, if you are able to make time to visit. So as you all know, IIT Madras, I think many of you have visited IIT Madras already. It's part of a national park in Chennai, so it's also an exciting campus to experience. And as I said, there are different modalities by which we can host both foreign faculty and students and postdocs. International collaboration is indeed both for technical and other reasons. It's quite important as part of this initiative. These are just the summary of what's all possible. I'm happy to discuss more details. There are short-term visits possible for senior faculty. I don't personally know the definition for senior faculty. There will be a committee at IIT Madras that goes through every application and proposal for a visit. So, or long-term visits, which are span a minimum of 3 months. I would just like to highlight that both these visits not only would take care of the local hospitality and accommodation, also includes financial compensation. And IIT Madras would very much like that we have either a teaching workshop or some kind of a short-term course, which would increase the interaction with the students on campus. Similarly, it's hosting foreign students and postdocs is also very welcome, and it's facilitated under this initiative. And it would be able to support both accommodation and monthly expenses, very much like how the graduate students and postdocs on campus already are treated. So they would be dealt with in exactly the same manner while they visit. Again, it would be wonderful for some of the students, postdocs from your groups to be able to visit IIT Madras. There is also possibilities for some of the students and postdocs from our labs to visit your groups, depending on what would help the collaborations most. Again, as I said, there are several opportunities. The moment we see some benefit for this exchange, let's surely discuss to see which of these schemes we take advantage of. In the longer run, it's also possible to take joint PhD students if there is merit in doing so, and that would involve different types of MOUs that could be evolved between IIT Madras and the foreign university. Again, this is something that IIT Madras is actively doing. It's not a difficult process. So if it's something any of us at IIT Madras and a foreign collaborator is convinced about, it should be, I can certainly help in facilitating this drafting of the MOU, because there are administrative and legal teams that make the whole process quite easy. There are one more exciting program that's recently been introduced at IIT Madras. These are meant for foreign postdocs. The program itself is called the Young International Fellow, which is aimed at hosting international PhDs and postdocs, international postdocs on campus here. There are a lot of details that are given on the link that I provide here. I will also send this by email. The program is indeed quite attractive. The salaries are on par with what a typical postdoc earns in Europe or in the US. And there are several additional research benefits as well, along with a lot of independence. The postdocs will have to identify faculty mentors at IIT Madras, but there is also a lot of freedom that goes with this program. So please do take a look. And if there are students of yours who are interested in spending some time at IIT Madras in India as a postdoc, this is a 2 years contract to begin with, which would be further extended. So this is ideally targeted at people who have just recently finished PhD, or they already have some postdoc experience and on their way to becoming a faculty member anywhere in the world. And there is also an IIT Madras postdoctoral program for Indians. This is called the IIT Madras Institute Postdoctoral Fellowship. Again, more details are provided in the link here. As I said, my idea is to essentially bring out the fact that there are several possibilities that exist. So it's about what would be, if we are convinced that for the research and the interaction, any of these are useful to do, we can immediately work out how this is done. There is a separate global engagement office at IIT Madras. There's a separate dean and a set of people running the this office. So there is a lot of help in hosting students, postdocs, or faculty members from anywhere in India or abroad. So please keep me informed about this. That is all I wanted to say. Before I finish, thanks everyone. And may I now invite Professor Murthy to say a few words, and we will wind up the meeting. Let me just check if Murthy is in the room. Yeah, I don't think Professor Murthy is in the room, so he's probably having internet issues or busy with something else. So he did want me to convey his extreme interest and happiness in being part of this initiative. As you have seen, there are also quite a few people from the aerospace engineering department, and we also have participants from mechanical engineering and applied mechanics. And as I said in the first day of the meeting, the aim in the longer run would be to expand so that this is an initiative or a center where there are lots of different approaches towards the common goal of geophysical flows that can be taken up here. So that's where I will finish. If someone wants to add anything or has a question at this point, let me know now. If not, we will keep in touch after the meeting.
Well, I just wanted to thank you, Mani, for hosting this and for the center activities.
Thank you. Thanks, everyone. Thank you, Amit.
Can I just add a line? So thank you, Mani, for this very nice initiative. And I will request very uniqueness of this center, what you have envisaged is the multi-dimensional, starting from observation to many scale of modeling. So keep that in view as we go with time. Thank you.
Sure. Thank you, Dr. Ashish.
Well said, Dr. Ashish. Thank you. Thank you, Mani. Bye-bye.
Any other comments? Okay, thanks a lot, everyone. It's been a long day on the Indian side and a long day is beginning in the US side. So we will finish the meeting right now, and I shall certainly keep in touch with everyone here. Thank you very much.
Thank you.
Thank you,
Thank
Mani.
you. Bye-bye.